This was the ammonium nitrate warehouse explosion that took place on August the 4th. I'm going to run a simulation of the explosion using exploCFD. We're going to do some calculations. It's a sort of mini virtual accident investigation based on obviously the best way to carry out next investigation is to visit the site physically and actually make measurements and extract data from there. However, since this is not possible, we're just going to rely on the information that's available in the data. I've just gone ahead and loaded a drawing of the port area of Beirut. This is simply just a map that was extracted online or from online, showing the area near the port. This is the L-shaped shape here. The L-shaped building here is the grain silo, and this is the warehouse that contained the ammonium nitrate. I'm gonna go ahead and select everything and exclude it, and it all goes purple. So basically I'm telling the software that all of these lines, just ignore them for the time being, and then I'm gonna go back and tell it which lines to actually pay attention to. You want to include the sort of walls of a building. The software should be treating the walls of a building obviously as walls, but not lines that demarcate sort of roads and other areas, because those are not real walls, nor do you want to include any text. And so to include these, you just select them and you right click and you select include, and they go black, which means that they're going to be treated as walls. I'm going to go back and exclude everything and load a pre-saved configuration of this data, which we've saved just a few minutes earlier, and you can see I'm just going to get rid of this ignition point here. We're going to go through that again, but you can see here all of the buildings have been selected as walls, the outlines of the buildings, and the roads, like this is Charles Helou Road, the sort of main road that separates the port area from the residential area nearby, is excluded. It's important to exclude things like roundabouts, like what I'm selecting here, and other lines, because if this line, for example, was selected in included mode, if you like, it will be treated like a wall, and it will block the gas that is expanding from the explosion. All right, so we need to set up the explosion. Now, one of the big questions is how much ammonium nitrate actually ignited. Now, if you looked at the videos, you would have seen that there were sort of mini explosions occurring long before the sort of Big Bang occurred, and many more explosions occurred afterwards. So the ammonium nitrate was reacting before and after this big explosion. So the question is, how much of the ammonium nitrate that was in the warehouse actually ignited? One of the ways to look at this, of course, is to look at the damage in the buildings, and you saw that the damage in the buildings was the buildings mostly on this side, where I'm pointing to, this side of the Charles Helou Road. Those buildings were received a lot of structural damage. There was a lot of glass broken. None of them were obliterated, whereas the warehouses that were in the vicinity of the warehouse that contained the ammonium nitrate, most of these were completely obliterated. This gives you an indication as to the level of overpressures available, or thresholds for overpressures that were available on both sides of the street, and we'll get to that in a minute. Obviously, we have no way of surveying the buildings on both sides of the street, so a better way is perhaps to look at the crater that was left behind from the explosion. Here's a photo of the crater. you could see this is fairly shortly after the explosion took place. So this is the crater. The crater diameter is of the order of 180 meters, and it is said that the depth of the crater is about 43 meters. So the shape of the crater, is something like this. It's hard to sort of look at the profile, hard to figure out the profile of the actual crater, but it would be something like what I've just colored in red. And that means that the volume would be about 12,560 meters cubed. If you want to convert that into feet, that'll be 443,552 approximately feet cubed. I'm converting it into feet because there's a relationship between the volume of a crater and the charge of an explosion. So the volume of the crater left behind from an explosion, the charge that's used to create that explosion, there's a relationship between that. And that's published in several papers. If you saw an earlier version of this talk that I gave, it had, I was using one particular set of graphs. I'm going to use another graph here that I think is probably a little bit more accurate. So if we look at this curve here, we can just place in or put in the apparent volume of the crater, and that we said in feet cubed is about 443,000. It's difficult to actually see the numbers here, but that's that 5 here, that's a 5, that's 500,000, so 443,000. And read it off the curve, and that gives us about 80,000 pounds of TNT. Now, 80,000 pounds of TNT is about 36,363 kilograms of TNT, and that is equivalent to about 114,000 kilograms of ammonium nitrate. The ratio of TNT to ammonium nitrate is 0.32 or 0.42, depending on the type of ammonium nitrate. We think that this was the lower one. But at any rate, it's the same amount of total explosive energy, if you like. It's just more mass of one type. So if we were using the sort of prill, we're saying 114,000 kilograms of this ammonium nitrate prill is what was used in the explosion. This is one of the videos taken of the explosion. It's right across the street from the port area. You can see this is the Charles Helou Street. And this is a view of the grain silo that was right next to the warehouse. And this, of course, is the warehouse itself. You can see that the ammonium nitrate reaction was well underway. It's hard to see here because of the shadows, but other videos show the orange hue of the smoke, which is a clear indication of ammonium nitrate or some type of nitrate. So the reaction starts to progressively increase. You can see these flashes of ammonium nitrate reacting, and then from then on, large amounts of smoke coming out. From then on, you start to see more flashes and an orange glowing region inside the warehouse, getting larger and larger until finally it becomes large enough to set off the Big Bang, which obviously sends a shockwave 500 meters to the warehouse. Obviously glass broken, so pressure at above 0.035 bar at that location. It's clear that the reaction was not initiated by a large explosive charge like a bomb or a missile, because if it had been, then the explosion would have been large to begin with. But this was a source of an explosion that was probably relatively small, nevertheless sustained, and the ammonium nitrate progressively increased in reactivity, or in reacting amounts, to be more accurate. So the ammonium nitrate increasingly reacted in larger amounts until finally you get that Big Bang. So if it had been a missile or a bomb that set this off, you would have seen the Big Bang right away, or a larger bang to begin with. But you probably would need still a sustained source of heat to set this off, because this was ammonium nitrate prill, and prill is not as easy to ignite as the liquid form. So you would have needed something like, think of something like a piece of glowing coal, which is hot and continues to be hot for a long time, long enough to get some of that prill melted and reacting. And once you do that, it progressively becomes larger and larger. So 114 tons is still one of the largest amounts that we've seen in history of ammonium nitrate reacting. Nevertheless, it's far less than the amount that was quoted before, which was 2,750 tons. So 114 tons is maybe about a 30th of that, or just under a 30th of that. A far less amount than you would expect to react, but clearly some of the ammonium nitrate was reacting before, and some of the ammonium nitrate reacted after the big explosion. Whether that was sustained, whether that big explosion was just simply a natural evolution of the increasing amounts is hard to tell, or whether there were reports that because that some of this might have been stolen and there was far less in the warehouse. It's hard to tell from this vantage point. So I can now place an ignition point here, and I can say I'm going to do a TNT equivalent explosion. I could say that we've got 114,000 kilograms of ammonium nitrate. The explosive TNT equivalent factor is 0.32. This footprint is about 180 meters, and this value, this is the correct density for ammonium nitrate, it's 1300. That's all there is. That's all it takes to model an explosion or an ammonium nitrate explosion in exploCFD. You load the plot plan, you select the lines that you want to select, and you put in the parameters relating to the amount of charge that you have, and then you set it off. You let it run. Of course, you need to place the dimensions. This was 1562 meters by 957 meters, and it was, and we'll take a cell size of 2.2 by 2.2, apply and close, and that's it. We can set it off. We're going to look at the results in a few minutes when we've given it just a few minutes to do its calculation. Okay, we've loaded the results, and we can take a look at the overpressure. You just need to add a calculator. There's multiple pathways to this. This is one of them. Data analysis is another. So you go calculator, just change the name to whatever you want to call your variable. In this case, it's overpressure. And we'll do this in bar. And so it'll be pressure with a capital P minus 101,325 divided by 100,000, and apply it. And you could see here the results for overpressure at this time step. Of course, you could skip through the time steps, create a video. In fact, we'll create a video in a minute. I'll just show you some of the time steps. Here's at 0. So this is the first time step, if you like. So you can see it's going up to 25 bar, the maximum pressure. And we could go to 5th time step, and obviously you start to see an attenuation in the overpressure. So we could set the scale from 0.01 to to say 10 bar here and go logarithmic, and that'll show the scale in a better view. You can see that the pressures in the early stages are very, very high. They're over 2 bar. Everything in this region would be decimated. Go to the 10th time step. At this stage, the pressure is between, you can see a lot of green, a lot of yellow, still a lot of red, so between 1/2 and 2 bar is the overpressure. Remember, this is expanding outwards to the sea, and this is approaching the this gap here represents the Charles Helou Strait, and then we'll go 15, allowed to expand even further. And as you can see, the pressures are dropping. It's still devastating pressure, 0.2 bar. Serious structural damage, and destruction of buildings that are not fortified. Go to 25. So now we're crossing to the other side, and you can see now, after it's crossed the Charles Helou Strait, we're between 0.1, let's say between 0.05 and 0.15 bar, okay, as it crosses the strait. And this explains damage in some of the cars that were crossing the strait, that were passing by the incident as it occurred. They are fairly close. 30, you can see the pressures drop even more. And then 39, till we get to the point where the video was being shot, which was likely to be from this location here. Okay, so the person who took the video that we showed earlier could see an angle of the silo, and so it's likely that he was here. So the pressure over here in this region here would probably be somewhere around 0.05 to 0.1 bar, between 0.05 under 0.1 bar. There are pockets where the pressure approaches 0.2 bar, but in general, especially high up, the pressure would be between 0.05 and 0.1 bar, and that's just enough to break glass and not to cause the building to collapse. That's basically what we saw in the videos, or in the video that we showed. To take a better look at it, I can change the scale range, and you can see that you've got a lot of green here, touch of yellow, but mostly green. It's between 0.05 and 0.1, 0.05 and say 0.11 or 0.125 bar in this region. Okay, so I hope this clarifies the issue. It wasn't 2,750 tons. It was somewhere around 114, 115 tons that ignited in that Big Bang. And there's a lot of reasons for this, a lot of rumors also going around that the amount was reduced over time due to theft, due to whatever it is. But it's clear from the crater that the sort of ballpark figure is around 100 tons, 100 to 200 tons, which is very, very different to the 2,750 tons that was claimed, or the arbitrary values that have been used in some calculations. There's a lot of uncertainty in this calculation. It depends on the actual area or the volume, the apparent volume of that crater, which is impossible to calculate without actually doing some measurements on the actual crater. The crater itself is probably deforming now, and as time goes by it gets harder and harder to calculate. But it's this is an approximation, it's an estimate, and at the end of the day, that's all the information that we have. The amount of this amount, 114 tons, is still a very large amount. The amount that was in the West Texas explosion was about 30 tons, 20 to 30 tons, according to some of the papers. So it's really, so from the crater analysis of the West Texas explosion, the explosion that occurred in the town of West in the state of Texas in the United States, the amount of ammonium nitrate that actually ignited there was far less, maybe 3 times or 4 times less, ballpark. This is still one of the largest explosions of ammonium nitrate that the world has ever seen.